So welcome to the channel guys again, and now we are going to discuss this LEETCODE jump game for hard problem. So here this is tagged as hard problem, but it is not so hard. I am explaining you why. We are given a array of integer and named it as ARR, and what we have to do, we are initially position we are initially at the first index of the array position at the first index of the array, and in one step we can jump from index I to index I plus 1 if it is defined mean uh, if it is less than array dot length. Okay, we can jump I minus 1 if I minus 1 uh, will be greater than or equal to 0, or any index j where arri is equal to arrj, and or I is not equal to j. Like I'm explaining you with the example, this if there is 100, then from this 100 we can move to this 23. We cannot move this side because I minus 1 is minus 1, that is not greater than or equal to 0, so this condition will false. And we can move to this 100 also because both have same value. Okay, and from this 23 we can sorry, I'm taking this example. From this 404 we can move to this, we can move to this, and we can move to this, sorry, only this last index. Okay, and what we have to do, we have to return the minimum number of steps we need to reach the last index of the array. It is defined we cannot jump outside of the array at any time. Yes, it is the satisfied with the condition. Like y answer is equal to 3 here. From 100 we jump to this 100 by taking step 1, then this by taking step 2, then this by taking step third step. In 7 we are initially at ending of the array, that's why answer is equal to 0. In this 7, from this 7 we go to this 7, and that's why answer is equal to 1. So what we will do, we are now focusing into the solution. Now we are given a function int min jump and a vector int arr. We have to return the minimum number of steps we need to be at the end of the array after taking these steps in any order according to us. We don't need to specify what order we will take. Like here you can see we just return the number of steps, so we don't return like from 0 to 4 3 9. We does not need to return this order as well. Okay, so what we do, we take a unordered map int and vector int. Why we take it? Because for each number we will store the occurrence of the occurrence of its index in our vector. Then int n is equal to ar dot size. Then we take a vector bool v n comma 1. We initialize it with true at each stage. In bool 1 is represent any number other than 0 is taken as true, and the 0 is taken as false. So for int I is equal to 0 to I less than n, like we are traversing the array, and what we do, map map of that number we are push back the index I. Like here in 100 of map, what we see, 0 and 0 1 2 3 4 5, 0 and 5. In minus 23, 1 and 2 in our map. Okay, in the vector of our that particular index of our map. Okay, then we take a queue. This queue will store the number of operations or the next operation index in which we have to do some operations, right? And we initialize it with 0 comma 0, and this 0 means our current index, and this 0 means the cost, the number of steps we hadn't taken yet. Okay, and we initialize v0 is equal to 0. We initialize it with 0 because at the starting index we have traversed the starting index. That simply means this. And we run a while loop while q dot empty, while q is not empty. What we do, we take an a q dot front dot first, b q dot front dot second. Basically here our a will represent us our current index, and b will represent us the cost of our current index, or we can say the number of steps we had taken for this index. to to reach this index from starting index, b will represent that. Okay, then we just do q dot pop. Okay, and if I is equal to n minus 1 means we have reached the last index, then we just return b, and we don't check further because in further steps our b will increase. Our b will increase because we have just input b plus 1 in our queue. So our b will be is equal to b or b plus 1. So our cost will be greater than or is equal to b at least. That's why we just return b. Okay, and now if our a minus 1 greater than is equal to 0 and we have not reached the that index yet, then we what we do, we a minus I is equal to 0 and q dot we push that index with cost b plus 1. Okay, similarly with here, if a plus 1 and a plus 1 has then the size of the vector array, the size of the vector. Okay, and if v a plus 1 is equal to 1 means this index is not reached yet. We do it with we make it 0. Similarly here we make it 0 and push back a plus 1 comma b plus 1, the next index, and addition of 1 in the stack. Then for each index I in our vector, like for this 100, this array will contain this and this. If our vi, that means v does not traverse that particular index yet, what we did, what we do, we make it 0 means we have reached that index, or we have traversed that index. Then we do q dot push I comma b plus 1. I is the index here which contain the same value as arr a of that a index and have no traverse yet, and step plus 1. Then what we do, we just erase our vector, because suppose if we are at 100, then from this 100 we add this 100 in our queue, then we are at and when we are at this 100, then we again add this in our queue, then from this we add this. So this makes a cycle. That's why we go TLE. That's why we just erase. You can use this or you can use this. I use this, so it's your choice. So we just return b here. This return statement is just for the sake of this int, because yeah, for a function which have any return type we have to return a statement. This will never work because at any cost we will at the last index at any point of our traversing. So that's why this statement will work, and we will reach the array, the end of the array. So you can see I am just showing you the summation. You can see a separate, I am showing you the summation, a separate summation as well. My net is doing some problem, I don't know why. You can see the same problem. Okay, so well, okay guys, I think you guys like it, and if you like it then please subscribe the channel, because in future you will find the amazing coding related content in my channel. So thank you for watching this guy. Thank you.